All right, so I'll give a talk on induction heating. I had done a talk about a forge last month, and a few months ago, I had done a talk on a little tiny induction heater that I think, who was that? I think Jeff had donated here. So this is a forge from last month. Motivated by the work on this, I decided that I would sort of redouble our efforts on a thing that we had picked up on Craigslist over COVID. I bought a $100 induction heater, and our kind of goal is to try to get up and running so we can play around with it. The first step, though, is to dig around and see if I could find an induction heating reference. And looking online, the very best reference out there apparently is in full compliance with the government's regulation for conserving paper and other essential materials, which should give you an idea of how old it is. So this was published in 1944. Which would have been World War II, an interest in learning more about high frequency heating of objects, mainly for war improvements in efficiency. So this chart here is kind of important. Up here is 50 megahertz, and then down here is 60 hertz. And then these are different effects on heating metallic materials over frequencies. So at low frequencies, like 60 hertz, you can heat things up, but you can't transfer a lot of energy. At sort of mid-level up to 10,000 hertz, you can get deep heating, and then up to about 50,000 hertz, or I'm sorry, 500,000 hertz or 500 kilohertz, you can get surface heating, and then up from there is really on the very outside edge of surface heating. So you're just heating very little skin of the material. So in short, the heater that we bought on Craigslist goes up to 450 kilohertz. So we're talking in the surface domain, not so much the through heating. Our goal is to use it as a forge, which means we really want through heating. So we're kind of in the high frequency domain. And you can see a long time ago, they had to mess around with a lot of different technologies to get useful signals because they didn't have ready access to power electronics like we do today. So they're looking at rotary generators, and then you've got these vacuum tube generators, vacuum tube oscillators, and up to electron tube for high frequency. Today, we could do all of these things with just standard off-the-shelf electronics. Wouldn't be anything crazy to drive power at these frequencies. So the general principle is that you've got a thing to be heated and a coil to apply a cyclic frequency into it, and then you can get the surface of that or through the whole material to heat up depending on the frequency that you're using. The thing to pay attention to understand is that the closer you are to the coil, the better the coupling is and the better the heating is. So if you end up being even as much as a ½ inch away, you're talking an order of magnitude drop in coupling efficiency. So it's really important to be as close as possible to the surface of the thing, or otherwise it doesn't heat very well. So back in the day, this is a 20 kilowatt machine at 9,600 counts per second, so 9,600 hertz. So this thing is huge to get this thing to work. And this was a rotary generator, so they would have had a motor inside of here driving a generator to run the machine that they were using. So the machine that we have is very small by comparison. Now, some of the things in this book might be hard for us to get anymore. There's just some technologies that previously existed that just are not quite as feasible today. The asbestos belt is my primary concern here. If we really want to do any kind of high-speed processing, we're going to need a suitable replacement for the asbestos belt. So it is a very good book. The interesting part is electricity hasn't changed since then, nor has kind of the bulk heating materials. So this stuff is all really still relevant. So this is what we bought. I was on Craigslist and I saw somebody had a induction heater for $100, and we went and picked it up, and the picture that they provided was of the chiller, not of the heater. So I had no idea what we were buying. But for $100, I figured it's worth a shot. So this is a 5,000 watt machine that we've got, and essentially it needs a 3-phase connection at 240 volts and a fairly good water supply. And then in this case, it's set for 450 kilohertz max down to about 220 kilohertz minimum. So we've got a reasonable range operation. The first step was figuring out how to connect to it. So the way they had done it is kind of this quick connect block. So I had to make some copper blocks and a Teflon sheet to protect us from contacting this grounded clamp. I think the clamp might be isolated, but it might not be, so I don't want to find out. And then the next step was getting the coil hooked up. So I wound a long coil, and with the hopes that it would work well. We'll find out whether that worked or not. I initially tried soldering it with a propane torch, but the propane torch couldn't come anywhere near touching the heat that we needed to get on that copper block to get the solder to wick. And so I ended up using the acetylene torch, and you had to get it really hot to get the braze to wick in. But it wasn't too bad once it got going. You can see the heat just radiating off of this thing. Then you get some, so you have to run the torch as a reduced flame. So if you guys have used acetylene torch before, this torch has a lot of excess fuel in it. And the excess fuel then is protecting our surface from oxidation. So if we had excess oxygen, we'd be burning up the surface of the copper the whole time we're heating it. But by running excess fuel, we're able to reduce the oxygen in the air that's around it and keep the whatever we're heating from absorbing the oxygen in the air. So that's kind of an important part for brazing. So anyway, I got this thing hooked up and turned it on and tried to run it. It would fault out on a high frequency fault. So this is the chiller behind, hooked up to here with the garden hose basically. And it would run and it would fault out. I think that's, yeah, so go on and then you try to turn on the heat and it would immediately fault out. This, in this case, low frequency. So I couldn't quite get it to work. So this company was based out of Milwaukee originally, and they've been since acquired 3 times by other induction heating companies. And so I had initially tried to contact them to get a manual from them. They were really hard to talk to because they wanted like $300 for a manual. And I didn't really want to put $300. I think we paid $100 for it. And so I decided not to pursue that. So Bob had asked, and sorry I missed it, if it's solid copper or hollow for water cooling. So that tubing is hollow copper tubing. So it's like the same stuff you buy like for your refrigerator or feed line off your house, something like that. And yeah, there's water flowing through the machine and then through the coil in parallel. So inside of the machine, in looking around trying to figure out why we're getting that fault, I ended up looking inside. So they've got this is a current shunt at the top that's monitoring output current. And then these guys are capacitors to help with what's underneath here. These big things here are MOSFETs. So the MOSFETs are switching our currents at 450 kilohertz. And these caps are to help with the gate capacitance on the FET and output capacitance to try and keep the FETs full up, basically. So the machine is fairly unsophisticated in that it's got, this is a 3-phase power rectifier. And then you've got a big bank of MOSFETs, a bunch of capacitors to keep things operating in reasonable ranges for current and voltage spikes. Current output, and then the magic part is the coil is an inductor, and then there's a thing called a capacitor tank. And the capacitor tank was probably a saltwater cap back in the day, which I bet is why they call it a tank. But today it's just some solid state capacitors that are in there, and that thing makes a resonance. So to try and figure out why my frequency wasn't working, I decided to short out my coil to make it really short. So I just got a bunch of zip ties together, zip tied the coil down, and turned it into like 1.5 turns as opposed to like 10 turns. And that was able to get it up and working still in a relatively high frequency regime. And so I called and finally talked to a technician at the company, and he had suggested shortening up the coil a lot and seeing if we get that working, and also taking out some capacitors in the tank to try and get this coil to work. So I pulled some capacitors out, got this coil working, then decided to put the capacitors back in and shorten the coil way up, and was able to get it to work. So this video here, you can see kind of what it looks like when it's running. So when it first turns on, it's up in the red region. So it's up at 450 kilohertz, which is the top right there. There's no current flowing, no voltage output, but the heat is ready to turn on. And then you can see the coil down here. It's insulated just with a shrink tube. I need to get some high temperature fiberglass protection on that, but at this point, the shrink tube works fine. And then this part here is the water supply that Bob had asked about. So the water is kind of coming off. This bracket here in the middle is copper, and then the rest is all fiberglass. And so it's all fiberglass to keep it isolated. It's also isolated from the chassis. So this thing is got a isolation transformer output to keep you from getting hurt. So then on here, the 2 halves of that copper block that I brazed together, and then you got the copper coil coming out with about a turn and a half. And then this is an old laser cutter chiller that we had laying around from some old CO2 lasers. And so we were able to repurpose that. So that's got plenty of cooling capacity for this guy. So we hit the heat on button, and now you can see that we're putting out current, about 15 amps at about 300 kilohertz and like 25 volts. And then when we put in a piece of, in this case, steel, that voltage is going to go up, and the current gets kind of a little wonky because when you put in metal, you change the induction, and so the resonance system has to respond, so it tries to maintain resonance at that frequency. So the system's doing some fancy adjustments in the back end to the MOSFETs to keep them in tune. And that piece of material that I put in is cold, so you can kind of see it starting to change color. Now it's going orange. And it gets really hot really fast. So that's what we're gunning for, is trying to heat things up. The problem and sort of the next step of work to figure out is whether or not our limit on the surface temperature is due to the skin effect of the high frequency output of this thing. Because we don't really through heat very well, and so I'm not sure why it won't get any hotter. It gets kind of orange hot, but it doesn't get like white hot or start throwing off sparks from oxidation. So we're not getting like really hot enough to be doing a lot of forge kind of stuff with it. So I have to kind of play around with it, try to see if I can rewind a coil or play with some of the parameters to get it to work better.
That was in real time?
But that was in real time, yeah. So I'm not no movie magic.
That frequency is the correct, but you would expect full sparkage.
Well, so Sean asked if the frequency we'd expect like full, like hotter output. And the thing is it's actually the current, the voltage, and the frequency all work together. But the frequency that we're at is only allowing the surface to be heated. So we aren't getting through heating. But this is a tube that we're heating, so it's pretty much all surface. In short, it's complicated. They're like all three parameters are interrelated, and I'm not entirely sure if my coil isn't wound tight enough, small enough, or if we're just limited on the fact that it's 5,000 watts, or if we're limited on the high frequency staying on the surface of it with the skin effect. It should basically like boil and slew off the outside of the material without heating the inside would be the normal, the more typical problem. So I have to play around with it and see. I think I'm going to try making my coil a lot tighter, tighter wound. The tighter it is, kind of in this left or right plane, the better the coupling and the better the surface effect. So, any other questions? Because that's basically my.
So since this is induction heating, am I correct in understanding like if you put a piece of wood in there, nothing would happen to it?
Yeah, so Kate asked since it's induction heating, if you put a piece of wood in there, would you get any effect? And the answer is no, nothing at all. You can put glass, wood. I tried aluminum. In fact, aluminum at 450 kilohertz should couple to it. In fact, high frequency is supposed to work specifically for materials that are harder to heat, but that still doesn't have any effect at all. So yeah, it's kind of interesting that way. So yeah, in fact in the book that I've got, they use oftentimes a lot of materials to control the heating speed and also the heat density, like the inductive flux into the material by putting inert things in line with it. But yeah, in this case, this thing's only heating up steel. So I've tried other things and it definitely doesn't have any effect at all. So other questions?
So is that also mean like insulation you provide around the piping doesn't confuse the way you use?
Yep. So the question was if putting like insulation around the piping affects it at all, and no, it doesn't affect it at all, unless it was steel. Like if we did a steel pipe or steel cladding or anything like that, that'll change the flux, but not anything like plastic, glass, plastic or wood, fiberglass. None of that makes any difference. Yeah, Sean.
So you get the insulation actually decoupling your steel from the copper, and like if you didn't have insulation,
Yeah, so if you touched it, you'd short out the inductor. And so you could short out across the inductor, and so all the current would go out of the machine into your steel pipe across the coil and then back in. So that would piss off our power electronics, which don't want to deal with the huge change in inductance while they're trying to maintain resonance. So yeah, you want to keep the coil insulated, but worst case, it would just spark. And if you really shorted it out, you might burn a hole through the copper because all the current is just flowing through it. But if you short out and provide a hot spot, essentially, you can burn a hole through it. And so you can accidentally melt the hole, then you'll have the thing spraying water out, which would be not so good either. Energized water too, if it was in contact, if the other side was in contact with ground, so that would be not so good. So yeah, a bit of an issue there. Yeah, so in general, what we probably end up doing with this is wrapping coils for specific diameters and then insulating those a lot better. So like with the fracture and things like that. Yes, Bob, your finger would be a-okay as well. I did indeed double check to make sure that it was isolated as it should be, and it is, and that you can feel the coil, but it's not doing anything to you. Like you can feel the fact that there's a resonant frequency nearby, but not in any.
What do you mean by feel it?
You can feel a vibration.
I'm
Like
just like in
your
the air.
finger is being vibrated by the really big versions of these that are like 100 kilowatt actually float the metal. Like when they're heating, the stuff's like floating in a crucible. It's like a ball of molten metal floating around. That's massive magnetic frequencies, not anywhere near what we are. But yeah, so my next experiment is you should be able to use this to heat a crucible, so like a clay graphite crucible or a silicon carbide crucible. So I'm going to try to see if we can directly heat like aluminum that way. So you aren't going to heat the aluminum, you're going to heat the crucible. So I got to try that and see if it works or not. So we'll see. I think we need to experiment a little bit more with this with a few other options before we disregard it as a solution for heating things up. Right now, it seems like it doesn't have enough juice to do a lot, but that might be just because we haven't wound that coil correctly or set it up right.
So when the workpiece heats up, what is the delta?
The heat shrinks at 19 degrees Celsius, or 19 degrees. Sorry, 19 degrees. Yeah, 19 degrees Celsius. So it's being refrigerated. Yeah, and the heat shrink also doesn't melt unless you make contact with it. So the radiance off because it's not in direct contact, it's in radiance. So it's radiating off of the solid piece of steel and hitting the shrink tube. And that shrink tube, so it's meant to be under temperature, so it just makes it shrink down a little bit more. It's not too bad. Any other questions? Anybody on the interwebs got questions? Hearing none. Right. Who wants to go next? Okay. Mr. Markus. So Brian's got that.
Can I step in your way, Marcus?
Oh, it's perfect. Oh,
Okay. Oh, look, I remember. You want me to move this?
Sorry.
Yes, my stuff is in the way.
I got it. It's all good.
Where's the camera?
It's aimed right at the corner there.
Like this one?
Yep. You are.
Oh, there it is.
Very. Get this. Few, more than a few. All right, Mr. Markus. Take it away. Sure.
Okay, I hope you guys can hear me okay. I'm mumbling at mask. See if I can make this work. So I'm Markus, and I am working on a connected smart scale. And you can see the engineering prototype. We got 4 load cells, 1 on each corner, and they basically translate a force, to push on it, or the scale is now upside down. Usually with this way, the thing you would measure you sit on top, but you can see the guts. So 4 load cells, 1 on each corner, and the load cell basically translates a change in force or load to a change of electrical property. So in this case, the resistance changes. Then each of those load cells get interfaced with a analog to a digital converter and a little amplifier, and that basically translates the resistance into a number that can be read by a computer. And then under the masking tape, a little breadboard and a microcontroller, like some ESP32 variant for people that are familiar with that, can be programmed with the Arduino IDE, and it basically has Wi-Fi built in. They're real cheap. You can buy this Amazon the 2-pack for less than $10, or $5 a piece. The whole assemble is mounted in and on the simple wooden frame, 1x2s and a 1/4-inch plywood top. And then as power source, I'm using a what do you call it, mobile charger or power bank. Sometimes you see people have those connected to their cell phones, and it basically supplies 5 volts and I think the 10 amp hours at 5 volts. That's roughly the capacity. So typically, if you Google load cell Arduino, you see that kind of arrangement. Here they use 3-wire load cells, and they're sort of in series and kind of add all the changes up, and they just use one amplifier and one analog to digital converter. And if you're interested, the load cell has basically the following schematic. You have a couple of constant resistors, R1, R3, Rx, and a strain gauge, which is basically a variable resistor that changes its value depending on how hard you push the load cell or what the weight of it is. So you supply power to between the points A and C, and then you read the voltage or between D and B. But for the most part, the thing you should remember, if you want to remember anything, it's a change in resistance that is proportional to the force that is applied to the load cell. In my setup, I'm actually using 4 load cells and 4 separate amplifiers, just to increase the accuracy. And it looks more like this arrangement. And as a comparison, I actually did buy like a commercial postal scale and took it apart. On the left, you see this thing still completely assembled, and you also see the bottom. It looks pretty similar to what I have. And then on the right, you see the cover off or the bottom off. And in comparison to mine, it's not that much different. You see a bunch of wires and what appears to be hot glue, and then one amplifier out there. So my prototype has more of a Home Depot look, and this is nicely covered by the bottom. Here's a close-up of the scale that I bought on Amazon. So, what is this all about? So this is going to be a scale that you're going to put somewhere where your cat hangs out. For Tesla, I'm not sure if you can see this. The people that are here can see it. There's a cat bed in the corner. So you can sneak this onto the cat bed, and then when the cat lays on it, you get a weight. And we have about 100 million cats in the United States. 70% of them are overweight, and 1% market share, $6 a month. For watching the weight, we'll be making almost $4 million a month. So this picture I took at a clinic on the west side that specializes in weight loss for cats. This is the before picture, and this is the after picture. So the cat did not change the color. These are 2 different cats. But when the white cat came in, she looked like he does. And it's actually kind of a sad story. Usually what happens is the owner has other issues, and the cat is basically just free feeding, and then turns into has obesity basically. But the cat, still gets around and is happy. But she is now on a weight loss program, and soon will be looking like this cat, except the color will not change. And how is this done? You find all sorts of weight loss tools. So this is actually a cat-sized hamster wheel. If anybody of you guys have gone to the Children's Museum, they actually have a human-sized hamster wheel. So they also make cat-sized hamster wheels. That is just one tool for cat weight loss. That was it. You guys have any questions?
Cats to the home, Markus.
I have 2 cats, and both cats, the food gets metered. They get fed 5 times a day. 5 times a day. And one cat gets 45 grams total, and the other one gets 50 grams total. And currently, I actually weigh them manually and then put it into some clumsy Excel sheet. So I'll be the first to try this.
How do you keep them from eating each other's food?
That is a very good question. So the 100 million cats are actually in about 50 million households. A lot of people have multiple cats, which actually is part of the problem. And you very often see one skinny cat or fat cat, and obviously the fat cat is skinny cat. There are technical solutions for that, and they often have the cat has an RFID implanted, like most cats in the US have, and the feeder opens for a particular RFID, and that's a product you can buy actually. So you can separate those.
I've seen those online. Do you have one? Does it work?
I don't have one. I just lock the cats in separate rooms. And my cats are very food motivated. They open doors, cabinets, they find dog food. So I'm not sure what they would do to the automatic feeder. I would like to try it, but there's probably a paw in there or 2 cats at the same time. Or something. They are relatively safe, but probably too safe for my cats. In the sense of they're probably break the door.
If you just alter the size of the thing, so you have that check it.
Yeah, that's a good idea.
So like
Like
it's
a-
the way the thing changes.
I still hope the
And then
cat.
I get stuck in.
I don't know.
Like that's a very good simple idea. I like simple. But yeah, you could make a jigsaw, make the hole a little smaller for the other cat. Separate.
Will this record the data for you? Really? Like,
So the idea is right now this is Wi-Fi. I also have a cellular modem. So it basically radios the weight into a back end, and clinicians can monitor the weight, and then can see if the weight loss goal is met. And talk to the owner, basically being in the loop.
Speaking of simple solutions, that cat said for the instructions for a skinny cat, got that on top of the refrigerator. He was the only one to get up there. Fat cat got his food on the ground.
Yeah.
He couldn't make the beat to the counter and the refrigerator.
See, and that's an exercise goal for him then too, where he's like, okay, I gotta get enough exercise to get on top of the refrigerator. Yeah.
Yeah, so these are all good ideas. My cat have about the same weight and the same agility. They can jump, I don't know, 4.5, 5 feet from the ground. So for my kids, I haven't really found a way to separate them automatic or simple way.
Since yours are of similar size, if you did feed them next to each other, what would happen? Like, would they still just eat it, like, since their food's almost the same amount?
They do, and they sort of trade dominance. So sometimes one cat eats the other cat's food. if they are separated for 70% of the feeding time, they're probably fine.
It's just Wi-Fi and cellular backhaul.
Yeah,
Does the SP32 do Bluetooth as well? Or?
I believe so. Yeah. So the idea is, you guys are not the average population.
Right.
So if you ask the average population, your Wi-Fi password, you probably lose, 70%. Then, your Apple ID to install an app, there you probably lose another 30, 40%. Then, if you have good, reliable Wi-Fi, what the scale is going to be, eventually, there's nobody left anymore that can use a Wi-Fi or Bluetooth-enabled scale. If you're technically inclined, you can do Wi-Fi, you can do Bluetooth for your smartphone, use it at the top. There's, lots of options. The one I would prefer is, the zero configuration at the consumer side. So basically, they get a cellular-enabled scale and just put it somewhere. The rest is all basically automatically configured, assuming that you have cellular servers where you are. But if it turns out the pet owner is technically inclined and says, "Oh, sure, I know my Wi-Fi password, sure, I can install an app," then you could make a version where you just leave out the cellular modem, save yourself $30 and have it Wi-Fi.
Well, if you're looking for a separate market, like my brother does a corn maze and he has to like weigh pumpkins and stuff.
Yeah.
But the point of sale system is square.
Yeah.
So it's like, it'd be nice if there's a scale, like the Bluetooth talk to my square system, and it would know prices per pound. Because like right now, it's like, have a separate scale thing, there's a number, then it's gonna type it in this point of sale thing, and then make its transaction, like add its line. But looking for a narrow market, smart scales, that might be a way to,
So what is that square thing running on? Is that
it's like an iPad.
iPad? Can you connect the keyboard to an iPad?
Yeah,
Yeah, you can connect.
So you use the Raspberry Pi Zero simulating the keyboard and then connect it to this. and
Right,
string
well,
together.
yes. Again, it's the same kind of people that are limited technical, that just want to work. Like I said, kind of dedicated hardware,
Yep.
So I think for what Markus, you set up like the GUI interface that you always run into it. Put that.
I think what Markus is saying is, if you're a good brother,
Yeah.
you might think,
Oh, yeah.
David,
You already asked me about this. I think so.
So this is your next project.
Yes.
all right.
Is there any remote people? What am I gonna find?
Yeah, you can hit chat and then see if they show up. See if, no questions from the internet people.
Does the audio work for the?
They do. They're certainly able to screen. In fact, I bet if Nick says something, we can all hear. The question is, can Nick hear us? That's the real test.
Well, thanks for listening.
All right, thanks, Marcus. All right, Kate, since I screwed all your stuff up, you want to go next?
Okay, so where am I supposed to stand?
Right
Where
there,
you
it's
are?
And yeah, right where I am. Because Brian's got a microphone on the podium. So you can set that over here.
I'll start with it right here.
I can van away the camera here.
Oh, good, okay. I don't need that quite yet, but can we do share screen for Chrome?
Yeah, we'll do that.
All right, so that should be good.
Excellent. Thank you, thank you. Excellent. Okay. My name's Kate, and I'm a scientific illustrator, so I do a lot of vector illustration, and most of my hobbies seem to be turning my vector illustrations into physical objects. I think that's really my niche, what appeals to me. So this is my latest excursion into that, which was learning silk screening for the first time for me. Over the 4th of July, I had a bunch of my family coming to Wisconsin, where we spent a few days together, kind of like a family reunion. And we thought it would be kind of fun camaraderie to have like matching t-shirts sort of thing. But we could have just ordered matching shirts, but I'm kind of sick of those ill-fitting t-shirts. I feel like I have a ill-fitting 2XL t-shirt from every event I've ever participated in. We call them sleep t-shirts. Tired of that. This could be kind of a fun thing to do together. Just the actual printing step is the fun part, kind of like, hey, we're spending the weekend together. So over the 4th of July, we did it. We did it outside and in the garage with the doors open, and it worked really great. I had a bunch of my family got into it. Some people just played badminton while the rest of us were having fun with the screen printing. I think everybody enjoyed it. Everybody brought their own shirt or tank top or whatever they wanted. And I made a handful of designs because people are all different ages, they have all different style. I did a bunch of kind of family-oriented designs. So this was my grandmother, who I never met. She died the year I was born, but they had these like matching family t-shirts way back then. So I made a new design based on that. I did like some kind of jokey family crest thing. So it was a lot of fun. And I was willing to do some level of investment in materials, but I'm sure I will screen print again, but I don't plan to do this a lot. So I had a limited amount of investment I was willing to do. And there was kind of some troubleshooting, even though there's like a ton of people with opinions on the internet, like some of them are professionals using professional equipment, and their advice was not true for the materials I was using, and on the other side as well. So I thought I would share with you what I wound up having success with. So we had on that weekend, the 4th of July weekend, we printed 24 things and amazingly botched none of them. We had to throw away 0 t-shirts that weekend. I think the screen printing angels were like shining on us, because I can't believe that we didn't ruin more shirts. So that was good. So the basic concept of screen printing starts with a clean screen, which I have a picture of there, which I don't have any left because I put designs on all of them. So it's basically a piece of chiffon that is stapled on frame, and I just bought them pre-made on Amazon. It turned out being really handy to a bunch of them that are all the same size, because for aligning things and setting up my system later, it was nice to just have one size to deal with. So that was something that I'd recommend. And these were not very expensive on Amazon, as you can imagine. Oh, do you mute somebody? Somebody's getting muted. Okay, so the gist of it is that I can use this photo emulsion, I'll explain, to cover the holes in the chiffon fabric everywhere except the design. So on the design, there are still holes. I'm sure a lot of you are familiar with this idea already. Then when this is laid down over a t-shirt and you put paint on it and squeegee it across, the only places that the paint is able to seep through and mark your t-shirt are the places where your design are. So bada bing, bada boom, works pretty well. So the way that you make the screen is a little more time intensive than just the actual fun printing. So all of this I did ahead of time in my basement before the family weekend. And a bunch of it has to be done in the dark. So you start off by taking that clean screen from Amazon and cleaning it off real good just to make sure there's nothing weird on it. And then spreading a chemical called photo emulsion on there. The easiest one for hobbyists is 2 parts that you mix together. And then in darkness, or at least not super bright light, you spread it on here, and I use a little nose scraper. You try to get a nice even coat on here and let it dry. In that state, the photo emulsion is still water soluble. So you're covering up all the holes with it, but you could wash it away at any time. Once it is exposed to light, the molecules in the photo emulsion cross-link with each other and it becomes water resistant and will no longer wash away. So imagine this is completely covered with the solid emulsion. You just need transparency. You could print from your printer and a very bright light source. And I am the very lucky person to be friends with Lima, another Sector67 member, who lent me her light box, which made this so easy for me. I'm really thankful that she lent that to me and gave me some tips. So you could take your transparency, put it on here, expose it to light. For me, 7.5 minutes, worked really well, which was the default. And then every place that has gotten exposed to the light will get cross-linked and is water resistant, but the parts of your design that will protect it from the light are still water soluble. So still in low light. You can rinse it under the sink, and every place that your design was will start to wash away. So hopefully you can kind of see that starting to wash away in the video. I didn't record the whole thing because I needed 2 hands, but hopefully you can see the design coming through. And at that point, you got your screen. Yeah, but if we want, I can now screen print something with one of these screens. It would be exciting. Maybe not that exciting. You want to handle the camera? Well, this is a very handy thing that I made here, which is just a piece of scrap plywood with the felt on it. I think this worked really well for the t-shirts because it kind of gave something for the shirt to grip onto, so it stayed in place. And it was kind of a nice squishy surface for I think it made the squeegee work really nice. And I also used it to help align things because I cut that to be the exact same size as my screens. So the ink is basically just really thick paint. This one, which is common for hobbyists, is water soluble until it's iron, and then it becomes wash safe. So just spread this up here. We can scoop quite a bit of it back into the container when we're done, so it's fine to be generous. And from the rest of the press, really hard.
How much does that cost?
Depends on if you want super fancy stuff. The metallics look awesome, but cost a little bit more. So I think you're looking at about $10 roughly for one of these little things. But we get a bunch. I have not run out of any color yet, so I guess that means you have to buy more than you need, even if you're doing quite a bit of prints. And voila! That little battery color. So at this point, if we put this in a washing machine, this design would mostly wash away. That has sometimes been a benefit because at home, when I was figuring this out, I would sometimes completely mess up a shirt. And if the color was not too dark, I could rescue my shirt by washing it and then getting a second chance. When the color this dark, it probably would completely wash away. But after it's ironed, it magically becomes permanent burn. I think that would be cool, especially because they make gel bleach, right?
Yeah.
Because I think you would want something thick. I think if you just use water, it would sink through these holes and go everywhere. But that would be a fantastic idea. Would gel bleach work? I don't know, but that would be really cool. What's that?
Next month.
Yeah, yeah, they do have, I have white ink, so I use white on the dark ones, that looks nice. Yeah, I had some inks that were kind of transparent, and I had to do a white layer first. With this setup, it's very hard to line things up, it's not like a professional setup at all, but I had some I think it was good enough, especially if the design's kind of messy anyway, you kind of make it look like, oh, I did 2 slightly overlapping layers of color on purpose, you try to pull that off.
You have to wash the screen, you screen like regular shirt.
So if I was doing another in gray, or this dark blackish gray, I could just set it down as long as I was decisive about setting it down and do another print. For another color, you have to wash it, and I always let it dry.
And the screens are not perfectly edged with other person.
So you can apply a removing chemical that will, change the photo emulsion back to being water soluble, and you can reuse your script. I had to do that at least a couple of them already, because when I was still learning, I messed it up. I do have to go watch this fairly quickly. I'm going to do that.
Great, thank you, Kate. Don, you want to go next? Maybe? Yeah. I'll bring the camera to you. There's actually a microphone directly above you, so we should be able to hear you online. My dog.
Well, this is the kind of thing only some retired guy has to have to keep his hands busy. I go out to weed best to buy steel, and it's very easy to do mostly 8-inch stuff. So I just need 20 feet of, I need a length of 1-inch steel strip. Yep. 20 feet of this. Washers, discs, angle iron, pipes. Very easy. And I have a chop saw and other tools to put things together. So I decided to make a family of Mobius strips, like the one that's hanging above your heads up there. That's a 1 foot wide, 20-foot piece of stainless steel. Chris butt welded the ends together to make it continuous. And that's a plastic Mobius strip. But for starters, I'll tell you the interesting thing about Mobius strips in just a minute. But this is just a belt. I took 4 pieces of that 1-inch steel, welded together, painted the outside red and the inside blue. There's definitely a difference. You know, I've always been interested in geometry, dimensionality, and topology. In geometry, we deal with the relationships among points, lines, surfaces, and volumes. And those are idealized concepts. A point has no dimensions. A line has no thickness. The surface has no thickness. Well, I have to work with metal, and that's the thickness. These are all 8th of an inch thick. So they have a top and a bottom, and they're different. The surface, there is no top and bottom. And depth of it, you know, that definition. So this is a belt, and if I'm on the blue side, I can't get to the red side without crossing one of the edges. There's no path from blue to red. If I simply twist the top 180 degrees and weld a similar shape with a twist on the top 180 degrees, that's a Mobius strip. It turns the entire thing into a Mobius strip. This is an object that has an inside and an outside, but no real top or bottom or anything like that. I mean, you can identify one side and the other side within the same side, because I can get from here to here without ever crossing the edge. Go around like that. And up here. So it's a one-dimensional surface. This is you've probably never seen one that looks like this, but this is another way of another implementation of geometry. Mobius strip. It's got a 90-degree twist on this side, 90 degrees on that side, 180 all together. So it has the same properties. Go from here to here without ever crossing the edge. This has two Mobius strips on it. That turns it back into a belt. Because one Mobius strip undoes what the other one did. So I can't go from here to here. This is 3 Mobius strips. Now I'm back to being able to go all the way around from here to here without ever crossing the edge. Any odd number of Mobius strips will do that. This is just a giant implementation of the first triangular one that I showed you. 2-inch wide steel instead of 1-inch. Like I said, there is no purpose to this other than just to make them. Just to keep the hands busy. I don't know what I'm going to do next. I mean,
How are you twisting them? How do you get the twist out?
I put it in a vise and take a put a clamp on the top and just twist it by hand. And by eyeball, I decided that they're either 108 degrees or 90 degrees. Haven't measured anything. But I've been very busy making things for people. I've made products for 14 or 15 global companies, stair steps, coat racks, trellises, all sorts of things. What do you call those things that trellises? Yeah, that's what plants grow. Yeah. Made some of those. About 30 or 40 friends. So I've been pretty busy making stuff. To get started, I stole this from Sector. This was from a scrap punch out. Someone's project 21 years. Someone punched this 1-inch diameter disc out of a 1/4-inch thick piece of steel. Painted one side blue and the other side red and edge black. Even though that's a 1/4-inch edge, it's a big edge. But that illustrates that this one is two-sided. I can't get from red to blue back across the black. Unless I use a trick like a Mobius strip. This has no applications whatsoever.
Stuff like that, kind of size material for the trellis that you were talking about.
Yeah.
Yeah. What kind of designs do you ensure the plant has it? The way to.
Got 6-inch by 6-inch grid of horizontals and verticals. The plants can climb up. They put out tendrils and pull themselves up. And they just climb up.
No Mobius strips for the plants?
No, I couldn't run it. But I'll tell you one thing. I found out make things out of very fine stuff like 1/4-inch rod. Extraordinarily expensive. We're supposed to make this instead.
Oh,
And it was too expensive to powder coat it.
I think you can incorporate Mobius strips in your garden scope.
Well, I could do that. Yeah.
Some of the skins.
I could. I've got a Mobius strip in my front yard. It's a stainless steel, like that, except it's not exactly. So it's fine.
You try climb up.
No, I actually thought about it. And I think I could probably make one out of glass, but I don't know how I would make one out of steel. And I don't work fast. I used to work at Bell Labs and I used to do glass work all the time.
Not separate fiber or
Huh?
what fiber or what, sorry. Where is that?
The Klein bubble,
Yeah, yeah.
it's a sort of a three-dimensional version of a Mobius strip.
Okay.
It's a one-sided surface, but it's more obviously three-dimensional. It actually will hold water. It is a bottle.
Okay.
In fact, I have a picture of it.
Markus, go for it.
So what was the original point of the Mobius strip?
Just curiosity about dimensionality.
No, I mean, Mobius had a point.
Oh, Mobius. Well, he discovered it. Okay, yeah. Re-entries. And that actually violates the topological rule about not being able to poke through yourself.
So what did he discover? I mean, I'm just
He
wondering.
just, he's the first one to describe it. He was Gustavus Adolphus Mobius. Although I can't really say it.
I think he was,
Are there any Germans here?
Mobius.
But my German just told me if you want to say it, I'm not owe you. Put your lips as if you're going to say, oh, and then instead say, hey. And you get a good approximation of the not oh.
all right. Thank you, John.
John, did you drive both of the Mobius strips for where?
Yes, they
I
do.
think
There
terms of
there are some
Really?
applications for
Yeah.
flexible movies.
they're gonna wear both sides.
Oh.
You wear it equally on both sides. You make a conveyor belt out of a movie strip. Or make a conveyor belt into a movie strip.
All right, so I think Dennis is gonna give a remote presentation next. Dennis, gonna take it away?
Yeah, you bet. Let's see, there's some video. During, I think the last meeting, or at least the last one that I joined, I mentioned I got a little CNC mill, and so I was looking for a project, and we have a gamer with a birthday coming up, and so I decided to make some aluminum dice. And so this was an exercise both in learning Fusion and also getting some practice with the mill. Is this screen share working? No response.
Yeah, looks good from my side.
Oh, okay, good, thanks.
You're all good.
All right, so I lost my browse window. There it is. So designed this starting with a cube with some fillets, and then had to add the pips. And I don't know if people have noticed that a dice often will have the one pip will be a little bit bigger. Now, of course, I can't rotate this very well. There we go. The one pip will be a little bit bigger, and I never really thought about that. And then I realized that you really want to counteract the amount of volume that you're taking out between the 1 and the 6. And so I kind of went off the deep end and actually calculated a different radius for every face, so that the total amount of volume taken out of each one of these is actually equivalent. So the 6th side is the smallest hole, and then as it goes for 5, 4, 3, 2, 1, they get increasingly larger so that the volume is equivalent. So that was a fun little rabbit hole. And then the next exercise was to actually be able to machine this, and I'm still kind of learning how to do this, but there's a bunch of different operations. The machine can't hit all of this at once, and so there's 6 different setups where it has to be clamped in there. So the top setup is the first one, and that's the largest piece of stock going into a vise at the bottom, and the top gets contoured away to kind of form the kind of rough shape of the dice. And then there's a facing operation. And in the prototype version of this was just a 90-degree standard facing operation, but you could see the lines it left behind. So I decided to get artistic and do that at a 45 that I think turned out really well. And then it does a little bit of an adaptive shape to give it the curve. And this is all with a big 1/4 inch flat end mill. And then it comes in with a 1/16 inch round end mill in order to really curve those off. So that's the top setup. And then you flip that over in the vise and mill away all the bottom amount of stock. And then you kind of repeat the same 3 operations: the facing, the adaptive, and then the round end mill. And you do that for the bottom, you do that for the front, you do that for the back. Each one of those is a separate clamping operation. And then for the left, and then finally you do that for the right. And hopefully if you lined everything up when you're all done, you end up with a dice. And so here is a picture of that first adaptive cut around the edge. And then here is a picture of the result before we filled in the pips with some acrylic paint. And then here they are with the paint filled in. And you can see a little bit, sorry about the dog. You can see a little bit of the 45-degree facing operation here. It's running horizontally there and vertically there. And then if I turn off the share and just go to the video, here's what the dice look like themselves. When they hit the light, you can kind of see the 45-degree thing. Something like that. So ended up making a prototype that turned out pretty terrible, but I learned a lot. And then based on what I learned from that, I improved it and then made a second and a third. And hopefully those will be good enough to give. Oh. So that's the presentation. Any questions?
It was awesome.
Can you hear us?
Thanks. What was the second question?
Whether you can hear them or not.
What kind of mill did you use?
It's the Bantam Tools desktop CNC mill.
Are you gonna make the 20-sided dice next?
I haven't figured out how yet, and it's one of the reasons, even though this was for a gamer, that I stuck with a simple D6 because I knew I could clamp after each operation to do the rest. And with the D20, I know it's possible, but I haven't figured out how I would do the clamping yet.
How do you like your mill so far?
So far, so good. It's each one of these 6 setups, it has to go in and probe. And if you don't get them perfectly, it offsets the design a little bit. And during the prototype one, that happened. And, you know, so I'm still kind of learning how to do all the probing. But so far, so good.
Now, have you rolled them enough times to guarantee statistical validity and probability here? Or?
You know, a family member suggested that as well, but
Everybody's just trying to burn your time. That's my point.
Yeah, I think it would be a burn of time because even I was just watching a video on statistics and they did a test where they they flipped a coin 1,000 times. And I think they ended up with like 467 to 5, whatever that would be, 33 or whatever. And so I don't know how many times I'd actually have to roll these to have any confidence that they're fair.
A lot of times, that's the energy.
Yeah. Sounds like a AI dice rolling machine that looks at the dice. For next month.
Yeah, if anybody has ideas on how to clamp a D20,
And wait, since they're a gift for a gamer, could you hollow out the inside to make it give 6s more often? But then cover it up so they look like legal dice, but they actually give 6s more often. That would be very nice.
Yeah, you drill the one deeper than fill the lead and then repaint the acrylic. Then you flip on the one more often, but you have good cover story because you specifically designed the size of the bits.
Yeah, it'd be real good to see.
I don't know if you can hear Sean, but he said you got to drill out the one deeper and then pour lead in it and then paint them all with acrylic anyway, so you can't tell that the one head is loaded.
nice.
It could work out well.
Yeah, as long as you're making your own dice, seems like you should put advantage.
I'd get in trouble if they were weighted though.
All right. Any other questions to anybody? All right. Thank you, Dennis.
It's good to see everyone.
All right. So Sadiq has got our last presentation. He's going to share his Sudoku solver. He's here, so we're going to try to manage echo. But Sadiq, you can unmute your computer.
Oh, I can. All right. I bring my computer over there.
No, you can stay wherever you want. Sadiq is remoting in from across the room.
All right. All right. I'll be sharing my screen. All right. Sure.
Can you hear it? Like, okay, can you see it?
I see.
Somebody share screen.
Oh,
And if you see the full entire screen, yeah.
Can they see it? Because I tried that, but it doesn't seem to be.
Yeah, so I can see you now.
Okay.
So, do you have like a presentation or something?
No, I just have the website set up and everything.
Well, I can see your video.
We don't need that. I'm gonna close it
Whoops.
out. Yeah, we can just close it because I don't know using it at the moment. Where'd we go here? So just close that. Then,
I don't think we're sharing screens here.
so let's close this.
Where's Zoom?
So Zoom is over here.
Oh, okay, all right.
You just share your desktop. Really, just
Yeah. Your entire screen.
I see your Zoom window, and now I see, whoa, a dev environment, Visual Studio.
Yeah, turn that back on. Yes. So now you can talk.
Let me mute myself.
Confirm that you can hear Sadiq.
Yeah. Oh, they do. No, all right. No.
I don't have any audio yet, if anybody's talking. I did hear that. Interestingly, your microphone for unmute is grayed out. Oh, because you're sharing audio from your app. If the app does not need audio, when you do the share, you can uncheck that.
So now they can hear us.
Yep.
Right, Dennis?
Yes, I can hear you.
Perfect. And then we're going to share your whole screen. So now anything that's on here is visible to them. So I think that's what you want.
Yep.
I want this one over here.
All right. Now we're good.
All right. So when I was talking about Jim's project, I brought up something called teachable machine, where I had to have a collection of images and basically do some classification in image, like machine learning classification, image classification. And I had the same idea of using that same technique to create a Sudoku solver. And so before actually coming up with this idea, I had written some C# code where I had to use Tesseract, but this is JavaScript Tesseract, but there's a C# OpenCV. It's called OpenCV, yes, not Tesseract. And OpenCV, they have some fancy feature tools where you can create some, you can do some OCR stuff on images and extract information from images.
So this could solve a Sudoku in the real world, like in a book.
Yes.
Awesome.
So I tried OpenCV, but it's too complicated. It's just too hard to maintain. It's C++. I mean, you can also do some Python, but it's too hard to maintain. So I'm looking for something that's easy. And so I was here arguing with Jim about it. Jim was like, come up with an algorithm and do some OCR. And I'm like, I did that and it's too complicated. I just need something simple and basic. So when I was trying to like do some research on like other tools that will make it easy, Tesseract came up, which is a JavaScript JavaScript library, and it was a cool thing. Actually, on their website, they have this live demo where they have like an image of text, and it does an image of text, and it actually automatically translates that text into like real text, the image text into like real text, which was cool. But I tried that, and the problem was that when I extracted the Sudoku, why is it opening? Okay. So when I extracted the Sudoku picks, like the cells, I had these lines in the image that I extracted, the cell that I extracted, and it confused the Tesseract library, which gave me multiple numbers, and I just wanted a single number.
So it would think it was like a 19?
Yes, a 19 instead of a 9. And it bothered me, so I was like, okay, I just want one digit, like one number. So I tried to minimize the numbers down to just get one number out of that cell. So when I tried that, it just gave me one. Like whenever it saw this, whenever it saw that line or even a dot somewhere, it will just give me any number. If it didn't know what it was, just come up with any number. And that was like a little, it wasn't good for me. So what I did is I went to Teachable Machine. I used to watch videos on YouTube. This guy called Dan Schiffman, and I like his videos so much. I like his videos, and he talks about Teachable Machine and other cool stuff about machine learning. And I was like, I should actually implement this. So I think, I don't know whether some of you may not have been here when I was talking about this, but the idea is to like get images. So for example, if I wanted to identify Chris from anyone here, I could collect images from each person at Sector. And for example, so I have classes here. I could say this class is for Chris, and the next class is for Sadiq, and then the next class is for Jim. So I create these classes for each person having all their images. So if I teach this machine learning algorithm or model, it will easily identify, if I give it an image of Chris that I didn't give it initially, it will identify that, hey, that's Chris, or hey, that's Jim. Which was,
how many images do you think you need to go on to create like a reliable model of, let's say, Chris's face?
So actually, this is the cool thing. So this is the cool part, is that you don't actually need even more than 200.
That's pretty good.
Yeah, you don't have actually need, because actually, so the machine learning, the Teachable Machine library, they have a Google pre-trained model behind the scenes. So all you're doing is just feeding it a little bit more data to like get it going. So you aren't really doing anything exactly, like you aren't really starting from scratch. You're starting from somewhere.
And how long does it take it to train the model on this 200?
So if you're training something from scratch, then that takes a little bit more time. Like if training a model from scratch, it will take more time to like make it be perfect.
Right.
Yeah, so it will actually take like even an hour or something, like more than that. Sometimes it depends on which algorithm
But
like
then it's
you're
done,
using.
right? So then if you show it a new picture, it just takes seconds. Right?
Yeah, it just takes. It depends too. It depends on the image size too. Also, it can. So a few things. There are things that there are few properties that will make it slow. I can't really say. I'm not like a genius about like machine learning, so I can't really say.
Might be.
I can't really say.
Yeah.
I can't really say much. My knowledge is like really small. So I used this. So what I did is I had already created this platform. Like what I did is I want a way of extracting images. Like sorry, not images, but cells. Initially, I had an algorithm where it can actually extract this whole Sudoku by itself using C#, which was actually a cool feature that I wanted to actually do in JavaScript. but it was a little hard, and also it took more like it was going to like it will need more time to like do everything. So I just gave up on that. I was like, I need something basic. I mean, it's an easy tool to use, so you don't really need too much effort to like move around
So
this
the
grid.
user will drag that
That
in?
around to show
Okay.
where the whole cell is,
That seems
which
to be
simplifies everything. So to like get to collect all the images I needed is I used the same platform that I created to like actually do the Sudoku thing. So all I had to say is, okay, I need all these cells and save them, and I kept feeding it Sudokus and collected all those cells. And I had my friend David to like help me sort these images out. So I
it's
said,
going to send just one
Cell.
cell to that
The-
algorithm.
yep.
Okay.
mhm. So what I did is to collect all these cells and classify them. So I say, okay, so these are all blank. Those are zeros. This is a 6. I collect all 6s. All cells have had 6s, put them in one folder. And then I fed them in here. So I was like, okay, so the blank images are 0. The blank images are 0. Why is it? Oh yeah, so the blank images are 0, and then the ones I give it the ones images and everything. And then I was like, okay, so start training. I mean, it took me a few tries to like get the perfect thing. I mean, I know I got the perfect thing. That's why I'm presenting it. So actually, let's try it right now. So right now I have the extract button, which will do the whole extraction process. And right now I don't have the thing to show that's actually happening. But now you can see that I have 0, 6, 7. I'm not sure whether people on Zoom can see this, but actually I can also zoom in for.
Did it call the 7 a 0?
Well, yeah. Well, that's a problem that I could.
Sorry.
Well,
Sorry, I should
I mean,
have mouth shut.
it's fine.
It's
It's fine. I mean, it's not the perfect. It's not like 100% perfect. It will. But most of the times, it's like. Oh, actually, that's wrong. So most of the times, it will like give me the right things that I need.
And
And
most easy Sudokus have redundancy in them anyway, right?
yeah, they have. So the key thing here is like. So right now you can see that actually that did a good job. So so you can zoom in a little bit here. So you can see that the 6s are 6s, 4s are 4s, 7, 6, 9, 8, 9, 5, 7.
Perfect.
So it does.
The terrible picture.
It's true.
Yeah, the terrible picture. So
It's a good test.
I can now click solve, and it will solve it right away.
Oh,
Yeah,
nice.
it'll just solve it right away. So everything is solved. Right now, I don't have like evidence to show that, hey, it's solved, but I have some images that I collected to have an example. So I have this 86 open. So
This man, if he's on these
so I have this open, and what I'm going to do is so now I'm going to bring that image up that has all the solutions. I don't need that. So I have the solution over here. And this is our unsolved Sudoku. Hopefully it works. So I click extract, and it does the extraction part, and it seems that it has done a good job. And 8, 6, 3, 9, 7, 7, 8, 1, 9, 8, 5. Yeah, so it did it. So it extracted everything, and I can just click solve, and everything is solved. And you can see that everything's just exactly the way. So the ones are ones, 5, we have a 5 there, we have a 5 there, and the 7, we have a 7 there, and the 4, we have a 4 there. So you can see that it did solve the thing. Yeah, and that's it. All I have to do is feed in, give it an image, and then open it up. It doesn't have the perfect user interface. I'm also like, this user interface needs some work because I need to like make it a little more convenient.
The programmer, not the UI. You do apologize.
Well, I also like UI design, so it bugs me when I can't like efficiently use an app.
Sadiq, if you changed it on the whole puzzle, couldn't it just tell you all of the numbers?
like right away.
Yeah.
Like instead of having another button that says like
Rather
solve.
than doing your square thing.
How would you train the
It's
algorithm?
just, well, in this case, it's to check to make sure that it extracted correctly.
Yeah.
Just
Oh,
learn
yeah.
how to-
So I don't have to display all those numbers. Like I can. They're already. Is that what you
Say why
meant?
they're two buttons.
Do you need to grid it? In other words, could the image identify multiple recurrences of numbers in the image?
So you can go to the beginning, if you don't grid it, it sees all ones all over the place.
Yeah. So that's
But
that's a
was
problem.
with- That was with a different.
Approach.
So you're saying it would have the same issue with the grid if you trained?
So it depends. Oh, actually, so then my next step is to train it in a way that I don't have to actually use a grid to like align it.
Okay, yeah, I guess that's true then.
So I could train it. So then this comes into image segmentation.
Yeah.
Where I can, instead of classifying, I can segment the image and give it a bunch of images. So I can say that, okay, this is an empty Sudoku. Let's actually.
Let's say I found a 7 and here's its coordinates.
So actually in image segmentation, what I could do is I could collect a bunch of these and then I highlight all the numbers that I want, or like all the cells and say, okay, this is a crucial part, this is a crucial part, this is a crucial part, this, like I tell it where the crucial parts are and then create another image. And also create another image with just a cell that, hey, this is a cell. And then create another image that, hey, this is an empty cell. And then like I have, so the process is tedious, but if you take some time to collect enough data, I can train a model that just does the image segmentation.
Because right now there's recognition software that'll put a box around every face.
Yeah.
It would probably be something like binary, binarization of the image.
Mhm.
Straight up just
Eliminate, yeah. I could
Anything
do that.
that's slightly shaded is fine.
Exactly.
The reason why I started with this is I just wanted something quick and easy that I can mess around with. And then my next step is like, I think I can challenge myself to see what I can actually try, because I want to learn how to train a model that does the segmentation part. Yeah, that's it. Yeah.
I think there is a market for this. I have paid for software to cheat on things before. So I'm like, there are people like me out there. I paid for an app that would help you cheat at Scrabble. I think I paid at least 99 cents for that. So I feel like there is a market for this.
Well, that's actually, so my goal here is to create an API that generates Sudokus and also solves Sudokus. So that hopefully if people are out there that want to like send a message to my API that, hey, I need a Sudoku, and then I can just give them Sudokus. Or if they request for a solution for the Sudoku, I can just give them the solution for the Sudoku.
I think Dennis had a. Dennis,
Oh,
you got a
yeah.
question on Zoom?
Oh, yeah, I was just jumping in. The same way that pose detector can detect different body parts and see where there are like eyes and hands and things like that, is you could train a locator to find the corners of the board so you wouldn't have to manually do that and things like that. But what you've got is pretty great. We've actually had a team working going on 3 or 4 years on essentially what you've built, except for license plates. So there's one neural network that finds plates in a picture, and another one that recognizes the characters within that, and then, takes the string, and there's, 5 other networks in there that do interesting things, but it's very similar to what you've put together. So good work.
Thanks. Yeah, but so my goal is to make sure that hopefully if I get more time, I can create a data set for my image segmentation part. And I'm still like reading more about it because I'm not like certain on how they create I want to see an example of a data set that was organized for image segmentation. I found a few but haven't looked into them yet because I haven't got time to look through. Yes, actually, Kaggle.
Not yet.
Actually,
it's a place where you're able to go and get like large free data sets, and not have to go and pay for anything. You can go and experiment and learn with these kinds of machine learning algorithms.
Yeah, I like Kaggle because I like to look at competitions. So they have this competition part where I can go there and look at what people have created. So they set up competitions. People do those competitions, and then I think I can pull it up.
Bad name.
I know, but it has good data.
I bet the domain was cheap.
Yeah, true.
I guess I didn't have.
Well, don't show everybody your password.
Yeah, hold on.
Well, I don't
It's
have-
fine. People can look it up and take a look at it themselves.
All right, so yeah, that's Kaggle, and I usually go there to do like data sets and look at the data sets. They also have competitions like over here. That's where I usually like to go and like look at what people have created. There was a coronavirus project that they had in here, competition, like trying to analyze predictions. I think I didn't really read it through. Go through it. Yeah.
That's amazing, Steve.
All right.
Yeah.
Thank you, Sadiq.
Yeah.
We can jump back to this Zoom, wherever it is. Maybe. And then you can kill off here.
All right, so I think that's it for presentations. Thanks everybody for coming. All right, so unless anybody else has anything else they want to share or talk about, we'll go off or slack for the evening and call it a day. So thanks everybody.